Let's start with the live demo. On the screen, we have the setter system design interview, then the cards for both the interviewer, the interviewer as well as us. For interview setup, we already entered this interview problem of designing a URL shortener and have provided some technical clues. Okay, now let's get started. In order to get started, we just need to click on join interview.
Let's design a URL shortener. Please start by clarifying the functional requirements, non-functional requirements, and scope you would prioritize.
Sure, so I'll start with functional requirements. First of all, I would like to understand how many users we are expecting.
Assume 100 million monthly active users and a read-heavy workload. Given that scale, which functional and non-functional requirements would you prioritize, and what would you leave out of scope?
Sure. So for function requirements, I'll start testing them. The first one would be ability to create a short URL. Then another would be ability to redirect on reaching those URL. Finally, I would also like to add the uniqueness here. So each shortened URL should be unique. What do you think?
Those are appropriate core, functional requirements. What non-functional requirements would you prioritize at this scale, and what would you explicitly leave out of scope?
Okay, for non-functional requirements, let me start listing them in a parse. First one would be availability. I would like my system to be highly available because that's the core part. Latency is also very important to be minimum, but in terms of priority, availability would be getting the higher position than latency. Latency minimized. Third point would be uh, I guess like scalability, since you already mentioned the user volume would be high enough, so the system should handle high redirect traffic incoming. That's it.
You prioritized high availability, low latency, and scalability. What would you explicitly leave out of scope for this design?
Okay, so for out of scope, let me write few. First would be authentication. I would not be doing any sort of authentication for the time being. Second would be any no analytics, I would say. So analytics would not be something I would be doing right now. Then I would only be keeping the URLs for I'd be keeping URLs for eternity right now. So like there's no concept of expiration. That's it.
You've excluded authentication, analytics, and expiration, with URLs retained indefinitely. Given 100 million MAU and a read-heavy workload, estimate average and peak create slash redirect QPS and annual storage.
Okay. So in terms of estimation, I would say the first thing would be obviously the creates would be lesser in comparison to the visits. So short URLs would be shortened once, but it would be uh, like visited multiple times. So create versus read ratio would be somewhere around 20 to 80. Then what else I need to think about? QPS. So by QPS, what do you mean?
QPS means requests per second. Estimate it separately for URL creation and redirects, both average and peak. What assumptions would you use to calculate those figures and annual storage? You scoped creation, unique short URLs, and redirects with high availability, low latency, and scalability. You also excluded authentication, analytics, and expiration. Now walk me through the workload and storage assumptions behind your QPS and capacity estimates.
Okay, so talking about the storage assumptions, I believe storage would be each of the URL would be taking around 500 bytes, and then we multiply it by 100 million URLs created in a month. So around 50 GB, I would say. Can we directly jump to the diagramming part?
Understood, we'll skip the remaining sizing calculation. Please describe the high-level components and end-to-end flow for creating and resolving a short URL.
Sure, let me work on this. I would start with the client, that would be user's browser. Then they would be sending the request. The request would first met by a request would first meet to a load balancer. Then the load balancer would be like distributing it across different replicas of the web app, something like web app replica 1, 2, web app replica 1, web app replica 2. Then we would also be having uh, associated database where the data would persist. And since once created, the redirection would not be edited. So along with database, I would also be having Redis cache. So I could have something like a DB to which these web apps would be communicating, as well as Redis. So what do you think?
I can see the main infrastructure pieces, but the arrows do not yet show complete create and resolve paths, and several service boxes are unlabeled. Starting at the client, can you walk me through both paths and explain when Redis versus the DB is used? Thanks, this concludes the interview. Your final feedback notes partial sizing evidence, while most design areas needed more explicit reasoning.
Cool. So as you have seen at an overall level, we are able to communicate through the whole process, and the AI interviewer can also see this canvas in real time whenever it changes. Not in terms of screenshot, but a kind of data structure which takes up the incremental changes. In the end, we also get this detailed final feedback where we can see our strength, the improvement areas, and what sort of things were not actually discussed. So, yeah, this is it. Thank you.